Hello everyone, welcome to my session. I'm going to talk about that how we can enhance an algorithm, a model that we're creating in Azure ML through some tips and tricks. So a bit of me, I'm Leila. I fly from New Zealand. I live in Auckland. I'm Microsoft AI MVP, and I'm interested in machine learning, in Microsoft machine learning topics, Azure ML, R with Power BI, R in SQL Server. And I try to speak and also doing some training and consultancy in these subjects. Also, I have a actually free book on advanced analytics with R and Power BI, how we can use it. So this is the main area that I'm really interested about this. Okay, so let's start. What is Azure ML? Azure ML is a machine learning in cloud. So that means that actually we can create, easily deploy a very fast machine learning in the cloud. It's located in the machine learning and analytics section. So actually we get the data from information management. It can be we get data from a database, from Facebook, from a sensor, and then you may store it in Azure Data Lake or SQL Server, and then you pass it through Stream Analytics to Azure ML, and then show the result in Power BI or other devices. So this is actually Azure ML location, so you see that how it's connected with the other tools in Azure. Okay. Before I'm start about how we can enhance, I want you to look at the Azure ML process and life cycle that we actually go through that. So the first step is to identify what is our business problem, why we need ML, why we are going to solve what type of problem. The second step, after identifying the problem, we should see that what data we need, how our data should be, how we have to clean it, what factor impact on our question. For example, you are going to predict the sales, so you should know that what factor impact on your sales. So collecting, doing some ETL process, identifying the attribute that we call it in machine learning process, feature selection is the second important process. After that, now we have our data. Based on our data, based on our problem, we are going to choose the model. Okay, so the algorithm that we are going to use. And after that, we have to set up the parameters. Okay, so this is the actually three main steps at the initial we should follow. After that, we should split our data into training set and data set, because this is a machine learning. It's going to learn from the data. So we have to actually train the model and then test the model. And finally, to see that how is accurate. Is it really good or not? And if it's not, we have to back to other steps. In this session, I'm going to show you that what sort of tips and tricks you should apply in these three steps using some Microsoft Azure ML components. I'm going to introduce you to see that. Okay. So the first problem was actually what is the business problem? Azure ML able to help you to do prediction, that we call it predictive analysis, help you to describe and see the natural trend in your data, that we call it descriptive analysis, and also help you to do anomaly detection. So there are other things like recommendation and time series, but the main focus is on these three. So I'm going to the first one, that is prediction. If your business problem is about predicting the value, that means that, for example, sales, you are going to see that how much sales you will have in next month or next year. So it's a value. Or number of followers in your website. You are going to predict the value. So we have to use the algorithm list that we have here as a regression group. So it can be different: logistic regression, linear regression, and the rest. The other thing is about you're going to predict a group. This customer stay with me or leave me. I will, this customer purchase a bronze actually product, gold product, or silver one. So that's actually, we are going to predict a group. Then we have to choose from the algorithm that we have here. Now, it's not always about prediction. Sometimes we are going to natural trend. We are going to find a similarity between our customer. So we're using the descriptive analysis or clustering algorithm. For example, K-mean clustering, we have it in Azure ML and we can use it. There are other algorithms that if you know, K-mode and the other, that you can actually use it. So here is just for we are not going to predict, you are just going to see the natural similarity between the customer. Okay. The next problem that we can solve in Azure ML is about anomaly detection. For example, bank fraud happen, or for example, in greenhouse, you are going to see the temperature that goes up and down suddenly. Okay. Now, so this is about business problem and what component and machine learning that we have there. The second step is about collecting data and cleaning the data. Yeah, definitely we have to do ETL process to gather data from different and do some, first of all, cleaning. But for each algorithm, sometimes we have to do a specific cleaning. For example, some algorithm that the nature depends on the distance, for example, KNN or the other, we have to normalize data. What is normalization? That means that we should bring data in the same scale. I have a data like this, that you see that, for example, first column length is 2000, the other one is 20, and the, for example, area is 0.45. They are not in the same scale. For this algorithm, I need to bring them in the same scale. So, for example, something like this. There is a component in Azure ML named normalized data that use some of the algorithm like min-max, z-score, and the other to help you bring the data in the same scale. Another one is about remove outliers or noises. You have a data, for example, range of 21 to 31, but suddenly you will see that there are actually two other values in the minimum and maximum size that is not in the range. So its impact on your machine learning is actually decrease your accuracy. So you have to do something. One approach is to removing them. One approach is to actually replace them with another value or doing some other. There is a component named clip value that help you to do that. So that's another one. And for other algorithms, like for example decision trees, sometimes we have to convert them to the different column. For example, I have a column named gender that has female and male. I want to, instead of having that, I want to have it as a two separate columns. So female gets 0 or 1 if it's female. If it is female, the other one is male, that is 0 and 1. So we have a component named convert to indicator value. So you see that beside the ETL, actually the data cleaning that we do as an ETL process, for each algorithm, we need to do some more data wrangling that related to that algorithm. And you can find these here. There are many other tools for data wrangling. You can write SQL statement there, write Python code or R scripts there to clean your data. And also there are other components like removing the duplication, cleaning the missing value, and the rest. Okay. So this is about cleaning the data. Another important, actually we should follow, is about feature selection. What is feature selection? Imagine that I'm going to predict the insurance charge for a customer. I know that age of customer, their BMI, are they a smoker or not, and the other information like number of children will be impact on the amount of insurance. There is a component named filter-based feature selection. I'm going to show you that how it actually works. So, can you see the screen? Yeah. So this is the data that I have for the insurance here. So this is insurance data. I do some data transformation, edit metadata, and then I'm connected to these component. As you see here, just visualize the result. Oh, not this one, sorry. Just a data set. If I show you here. So it shows me that how attribute like they are smoke or not, their ages, they actually BMI, how is impact on charge. So it's kind of correlation analysis. So it says that, for example, 60% if they are smoke or not will be impact on their charge. Their age range have 53%, that is actually high, more than 50 is high correlation. But for example, their BMI is 11%, is not that much correlated. This is a correlation analysis. So also, if you click here, you see that we have a bunch of correlation analysis algorithm that if you want to try different, we can use this. For example, I'm use this one, you can use the other algorithm for that. Okay, this is all about this. Back to the slides. Okay. Another step for cleaning the data is cross-validation that we have. What is cross-validation? The normal process that we follow for machine learning is that we have a data, we divide our data set, some parts for training, some parts for testing, and then we apply the model. So this is a normal way. But imagine that I have a data from a store. This store has 3 different branches. One in, for example, in an area that more students come there, another in an area that more people who works, and another area that most of people are elderly people and they are our housewife. So what happened actually? They behave differently. If I apply one algorithm in these data sets, I get inaccurate because the specification of the people that there is not correct. So what I'm going to do, I'm going to first divide my data to 3 folds based on the nature of the data. So first, data that has more students, another one is the people who work, and another one for the people who are mostly at home. And then I apply the model in each of them to see that how much accuracy I will have. So we call this process, that means that we are going based on the nature of the data, we do apply the machine learning then on cross-validation. We have a 2 components named partition and sample that helps me to divide my data set into 2 different folds. And another one is a cross-validation. I will very briefly show you that how it works. Okay, so again, insurance one, this is the insurance data. If you look at here, I'm using the algorithm, for example, boosted decision tree. This is the component that helped me to divide my data to the different folds. So here, I'm just saying that I want to divide data in a random to the 5 different folds. But if you have any specific role to divide your data, you have the you have the one who says that I want to customize. I want this data, for example, with this specification being fold 1, this data with this specification becoming fold 2 and the other, okay? So this component help you to actually divide your data, and then actually I connect the result to the cross-validate model. And if you look at the result here, if I just click perfectly, okay, what I have here. So you see that the first column shows the number of the folds that I have here. So I have 5 main folds. The number of the actually value that I have has been here. So for example, in the first fold, I have 267, and as you see, it's kind of divide eventually. Okay, so what's the rest? The rest is the evaluation result, is a kind of the error. So it shows that if I apply my machine learning to the first fold, I will have this amount of error. If I apply it to the second fold, I will be. So you have an idea that how's your model will be, how's your data should be there, and how you can apply machine learning, and how they are accurate about them. Okay, so back to the slides. Okay, so this is the second process that we have in machine learning. The third one is about choosing the model and set up the parameters. They definitely impact on accuracy of your algorithm. Imagine that I have a data about consumption of the coffee. So people actually consume more coffee at the morning, and because it's going to afternoon, they want to sleep, they consume lower coffee. So you see that the trend of the data is not linear. It kind of has a shape, has a S shape here. If I'm using the algorithm like linear regression that is able just to predict when the data is linear, I get lots of error here. So the algorithm linear is not good for this model. So it's really important that before you're doing any analysis, you see your data, how's your behavior of your data, and then choose the model, because definitely is impact on accuracy. So this is for choosing the model. There are other things, I'm just saying the example. Another one is about setting the parameter. We have to set up the parameter that we have in our algorithm to avoid two different problems. One is to be biased or underfitting, and the other one is about overfitting. So what's mean and how we can avoid them? Imagine I have a data about coffee and time. So here I have the time of the day and the number of the coffee. If I consider for the machine learning, I consider all of the data points that I have. Some of them are noises. So for example, maybe a person consumes coffee at 8 p.m., but it's just something occasional. It's not always the norm of the data. So I'm consider all of the data point that is not correct. I'm focused on the noise of the data. In this case, we call it as a overfitting. That means that I'm pay attention even to noises. And in other case, maybe I'm just focused on a consumption of the coffee from, for example, 8 a.m. to 10 a.m. Definitely increasing. And finally, I said that people consume more coffee from morning to evening. That is not correct. So this also not. So this is the thing. So it's really important. This is overfitting and underfitting. How to avoid them? By parameter selection. So we have to set up the parameter for each algorithm to avoid them. So for example, in clustering algorithm, we have a number of cluster that we should specify it very correctly. Or for decision tree, we have the same. There is a component name, I didn't put it, hypertune model that try different parameters that we have in a model, and based on them, we tell us that what's the accuracy and what is the best accuracy for each model. So let me actually show you this, the last one. So yeah, I have a decision tree algorithm here. So as you see, I have 4 parameters to set up. So if I click on the algorithm, you can see the 4 main parameters here. I'm using a tune hyper model to help me to see that what's better, actually what parameter I should have. So as you see here, I have about 180 different combination of the parameters. So the first row says that number of the leaves should be 2, if 2, and number of the leaf instant 50, learning rate this. What's the error what's the accuracy I will have? So it's try it for all different combination of the parameter. And I look at this and I see that in which parameter setting combination I have lowest error. So I choose that one. So that's actually really impact on accuracy enhancement. And yeah, just all this. So you see that how in different steps of machine learning, for choosing the model, from cleaning the data to choose the parameter is really important to consider some specification and help us to actually increase the accuracy. Oh, thank you. Thank you for coming to my session. If you have any question, I will be here. So after the session, if you have any question, please come. Thank you. Thanks so much.